Hello everyone, here is the Dongli 2021 video course. In this lesson, we're gonna look at the principles of color and clarity of a picture. Now, we see this picture. The flowers are very beautiful with red, purple, yellow, white, and the green leaves. So, what is the relationship between these different colors and how do we understand or use them? Okay, let's talk about the three basic properties of color. The first hue is red, orange, yellow, green, cyan, blue, purple. We fall into roughly 7 categories, but there are only 7 colors. That's not true. The clothes we usually wear come in different colors, so let's take the color palette in Photoshop and click here and drag it out. Then zoom in. Okay, let's look at the far right hue. We first select a color on the hue and then we can adjust the color on the right. We first select a color on the hue and then we can adjust the color on the right. Each of these points has a different color between the red and the blue and between the purple and the red. They all have a lot of shades of white in them. So there is actually an infinity variety of colors. How come we have so many colors in this display? And that's gonna talk about our color model. Let's reset this window first. Then look at the picture, where people have studied and found that one color can be mixed with another color. You get a third color like the blue circle and the red circle, and the overlap between them is gonna be purple. And then people looked further and found out that we actually only need 3 colors. A mixture of red, green, and blue can represent almost any color by adjusting the proportion of the 3 colors. This is called the RGB color model. R is the red letter, and then blue, green is RGB. Now go back to the picture. This is a very colorful picture and we use the straw tool to select the color. Open up the information window here. Every time we move the mouse over a color, it will display a set of RGB numbers. These 3 numbers are the concentration of red, green and blue, and these colors are combined to produce the current color. For example, in our current red flower, 253, 29, 209. So that means 253 red units, 29 green units, and 209 blue units to get our current red. Then the green and the yellow correspond to a set of RGB values. The RGB value is its hue. RGB color mode is a very popular color mode on all kinds of monitors and electronic devices. But there is a special case where when we're gonna print an image, we sometimes notice the color of the image that we're painting. It's different from what we see on the monitor. To make the color of the image on our monitor as constant as possible with the printed image, we can change the color mode of the image to CMYK in the menu bar image. The first mode, now check on the RGB, and then we can change it to CMYK. Click OK. We can see that the picture is obviously darkened. But now, with this color, the color of each part will give us a much more consistent print. It doesn't change much, but generally, the color of the CMYK or printed image is a little bit less saturated than the color that we see on the monitor, which means that the color may not be as bright. The second property of color saturation is purity. The color light that we break down with a prism can be said to be 100% protected. So it's a very colorful, but in general, we can't have such extreme situations in real life. Basically, the color is always mixed in with other light, so it's not that saturated. How do we adjust the skin of a gang piece? Menu bar, image, and adjust it. Vibrance. click on it, we can easy to find there are two bars called vibrance and saturations. Vibrance, we can understand it is saturation of intelligence. It means that when he adjusts the picture, he will automatically calculate and let you have the overall picture. It is a little bit more harmonized and it's a little bit more crude to just saturate the image. For example, we reduce image saturation when more and more low. If the saturation is low, the whole picture becomes black and white. If we were able to increase the saturation to improve the picture of the contrast between the more and more bright colored color is more and more clear picture of the administrative levels will increase. This is our situation. Okay, so the third property, lightness, which is the brightness of the color. How do we adjust the brightness of an image in this case? Image adjustment. And then the brightness is good and the contrast is good. So let's try to lower the brightness of this image first. Image is more and more dark. Increase brightness. Image is more and more brightness in the proper position. Bad is too light or too dark. So what is contrast? Contrast is the difference between the brightness and the darkest parts of an image. You can think of it as the gap between the rich and the poor. In this picture, for example, the gap is so small that the whole picture is bright. The contrast with the fat is not obvious. This picture will appear slightly lighter overall and then softer. If you have a very high contrast, you're going to have a much more structured image, and the contrast is going to need to be in the right place. So, in addition to the three basic properties of color, we have to add a concept called color temperature. So, what is color temperature? Basically, it's the temperature that a color gives us. Is it cold or is it hot? Okay, let's look at a couple of elements. First, we will look at the picture. This is a picture of a world of ice and snow, so it's very cold, and it looks very cold at first glance. What is the color of it? It is mainly blue and deep to find a variety of different colors as well as some white. That actually the ice sky right the scene is blue section. Let's have some actual photos. This is the next special one. Alright, can we go to the scene in the picture of the damage to the land? The land is actually self-colored. Snow and ice are not blue at all. Why do we paint the ice with blue rice to make the earth cold? Because blue has a very low color temperature that blue can make us feel cold. So let's look at this picture again. This is a fire, which gives us a very warm feeling. And then you have this map of deserts, which at first looks dry and hot, and then very hot. So why does the temperature of these pictures make us look warmer and warmer? Because of their colors. Yellow is actually the color of the flame, which naturally makes us feel very warm and hot. Blue is the lowest color temperature, and yellow is the highest color temperature. In addition to the other colors, what about their color temperature? The order of red, orange, yellow, green, cyan, blue, purple connects the colors into a ring. Let's look at it. Alright, yellow has the highest color temperature at the top and blue has the lowest color at the bottom. Let's switch positions. The other colors were arranged as they got closer to blue for 2 weeks. The lower its chromaticity is, the closer the yellow is to the city, the more its color temperature is high. The concept of color temperature is not a fundamental property of color, but it can be very useful in our daily composition, photography, and painting. Let's look at an example. First, the light on the stone gives a warm feeling. Other places feel cool, give person a feeling of big temperature difference. Here is a color temperature application in our daily pictures. We talked about the three elements of color in the class. The first color is like we added the RGB color and standard and the CMYK color standard. Saturation, which is the purity of freshness. The meaning of lightness is brightness. And then we added a concept called contrast. Finally, in addition to color too, we added a concept called color temperature. Okay, as the saying goes, theory should be applied to practice, otherwise, what's the use of it? So, what about the theory of color that we've been looking at today? Could there be a practical case where we can use the knowledge? One is to make the picture clearer. Before we do that, let's think about what it takes to make a clear picture. First of all, it has to have enough pixels, because only if there are enough images, it can express richer picture details. For example, this picture, let's zoom in. We can still see the flowers and the leaves and the petals. If we have them, make it 10 times bigger. Okay, it's all about mosaic. Nothing, so few pixels. It can't possibly express what a flower looks like. If you have fewer pixels, think about the indicator light at the zebra crossing next to the river. All it can show you a little guy walking around, and it can't show you anything in detail because he has a few pixels, right? Well, if we want to optimize the sharpness of an image, the first thing we need to do is increase the image cable of the image. So, how much pixel size is appropriate for an image? There's a number here, which is the picture ruler that we talked about before. 1080 pixels, it's 1090/20 by 10. And this is the high-definition version of a lot of our monitors today. The universal size of our cell phones and our computer screen is 1080 pixels for most HD. If we look at this number, it could be roughly equal to 2 stems times this. Remember this number, 2000 pixels by 100 pixels is probably fine, but if you want to get a little bit clearer, you can say 3000, 1500 or whatever you want to go up. But if you want to go up a little bit more, you can go up a little bit more picture. The volume will also increase accordingly. For example, Photoshop software may run slower. If your image pixel size is too large, so let's say 2003-1000 is a standard HD size. Let's press Ctrl plus Z to restore to the previous step 1 and then zoom in. Except for the pixel size, the second thing I want to talk about in addition to the pixel size is how to make the image sharper. Let's look at two images of material. First of all, this one, if we look at this picture, the part of the sky is very pretty, clear, and we can see the stars. And then you can't see the stone underneath, except for the light. So why can't you see the detail in the stone? It's obviously too dark to see anything. If it's too low, it's not a good idea to see the details. So let's look at the one again. And this is an example of the opposite. We see this guy and the beach in the background. We plant the guy first, and then you see if the beach is blurred. It's hazy. What is the reason why this picture is not clear? If the maximum degree is not too high, the maximum degree will make us not see the picture clearly. So we have a phase where we have a clear image that needs to be kept at a reasonable level of brightness. It can't be too dark. and it can't be too light. So in addition to grams, let's look at two pictures. Let's look at this picture first. Can you see the boundaries of this picture clearly? Let's cut it. First of all, there is the color part, the boundary you can have to clear the ring. It is not easy to divide the edges. Then crop the top part to see if the black part is easier to see. This is called contrast brightness contrast. The brightest place and the darkest place, it has very high contrast, and that's where we come to the next conclusion. Appropriate increase in contrast can make the picture clearer. Let's take a look again. Let's go back to the color picture we had before and let's go in now. The image adjusts, goes into its saturation. So let's do an experiment. If we now take an image and desaturate it very low. Now we're at our lowest saturation and we're going to see the whole picture. Not only the gray color is gone, the color is basically gone, but it becomes gray and hard to see. If we increase its degree of harmony, is there a feeling that the painting is becoming more and more clear? The contrast between the color more and more bright products, the picture lets us feel more clean, clear, level more abundant province. The distinction between content is even more shrinking, and this is a very simple thing to talk about, and that is appropriate aim saturation can improve the clarity of the picture quality. We can cancel it. So let's talk about the fourth thing that we need to do to make the mesh clear. So let's zoom in on this image right here. So if we look at the top part of the equation, it's much clearer than the bottom part of the equation. So let's think about what's the biggest difference between them. The difference is that there are clear boundaries between the contents of the picture above, such as the direction of flowers and leaves. And between this flower and this leaf, you can see that there are about 3 lines in the middle that there are boundaries, and you can see here. This one is a little bit puffy compared to this one. I can't see it clearly, but the edges are not obvious. In other words, whether a picture is clear or not mainly depends on whether its boundaries are clear enough. So what's the last way we want to blur an image? Stroke their border better. So it's a very simple way to do it. Basically, it's divided into 3 steps. First, duplicate a layer and turn it into a smart pair. And then I'm going to drag the image over here. And here is the copy layer. I'm gonna say OK and select this layer up here. And I'm gonna right click on it and convert it to smart object. What happens after we convert the smart object and then we will stroke it and we can change it anytime. You can't change the normal layer after you manipulate it, but you can change the smart object anytime. We are now in the second part and we go down to the bottom of the filter. Then click high contrast retain. What high contrast to retain the high contrast? What place is not is just a part of the border. Are reserved to the high contrast is just a part of the border. Okay, click high contrast reserves after its adjustment is also very simple. Dialog is a problem of strength. Actually, we only need to display outline of a boundary. Can be a little bit like 1-1. I'm gonna say OK, and now I have this layer that's struck on, and then I'm going to go to step 3. In the normal click here, this is the layer blending mode. It's like we just said a layer, agent, can object. And the mixed mode, and so on. These tools now because you may not have the basic operations of a learning software. So you also don't understand. I will give you in this simple talk about specific details about the interpretation of these functions with next phase chapters. Detailed explanations of these functions are given in the following sections. Okay, so we're going to go for linear light, but it's like a strong light. You can use any of these in this bar, and we're going to go ahead and click on linear light here. And then we can double click on this high contrast, and we're going to go ahead and do that again. Let's set the teaching values one piece apart. Okay, so we'll say okay, and we will have this stroke down, and we can turn it off by clicking on this little eye in front of the mesh. Let's see how that compares. The edges of the flowers will be much more noticeable, and that's the fourth way we can make a clear image using high contrast retention and stroke. I'm going to pick an image and I'm going to use what we just talked about. 5 ways to clarify the image to do a concrete practice. Hope you can use, we provide the material. So let's practice with you and see what you can do with this. And then the size of the images is in here. And now its width is 1024 and its height is 1478. Let's double it. Okay, and then zoom in on the view. So step 2, we will look at the brightness and the contrast. The degree is a little dark. Bad brightness appropriate to add little gram, some seasoning, 20, and then the contrast. You cannot increase the contrast too much here, so let's increase it. 10 units, good click, okay. Where's on the third term? Saturation image, adjust the natural saturation we have increased, the natural saturation appropriately. We filter the noise in the fourth item to reduce the noise. Use the highest intensity for the highest retention detail for the highest noise. And 50% sharpening detail, this is my habit. Click OK. Then we go to the fifth term, which is the high contrast, and the retention hasn't changed. I'm going to double click on this group and I'm going to unlock it. And I'm going to say OK and then copy the layer. OK, 2 layers and I'm gonna say OK, and I'm gonna take the top layer and I'm gonna do a little bit of editing on it. But before that, I'm gonna convert it to smart object. And then, what are the remaining high contrast values of the filter? It doesn't matter for the time being. I'm going to hit OK about 40, and then I'm going to set the blend mode to linear light. Then adjust the stroke level. Okay, so let's save this image after we save it, and let's just close it, and let's now open up the original image before optimization. Let's give him 2 pictures and pull his fluid head, and let's give him 2 pictures. Let's take a look at the effect of their degree of cleanness. Okay, so that's the main point of this lecture, and I will stop there. Then, in this lesson, we will focus on the basic theory of color and use this knowledge to optimize the operation of image clarity. And we're going to talk a little bit about why that's the case in the course of the course when we talk about how to do it and why. This will not only help you to understand and not make you confused about how to operate flexibly after learning OS. You don't need to worry about these forms. Then, from next class, we will explain the specific functions of the software and how they are used in practice. See you next time. Goodbye.